Hello everyone and welcome back. Today we will continue our ls implementation. As you remember, ls shows the list of directories in our terminal. It is listing directory of contents, and you can check the manual page as you can see. If you haven't checked the first video, go and watch it. Today we will continue with the second part, which we did in the first. We parsed the options, we gathered the paths, we were doing some debugging, which is we don't need at this point. And now we will continue checking what is in the directories. We will read it, we will sort it, and then we will print it. So yeah, this is the more difficult part of the project. And so basically, just to give you an idea, we will be printing first the directories. So let's say we have multiple directories. It will be like the one, it will have like file1 and file2, and then I will have second directory, another file A, then file B, and so on. So I will make a for loop which will int I equals 0, I is less than directory count, and I plus plus. So we will check our directories. The default will be the current directory, which will be dot, and we will also want to see what's in the current directory. And for this we will make some functions, some structures, and yeah, you will see everything by time, step by step. Okay, so first let's check if we have more than one directory. In that case, we will print the directories. As I said here, we will print directory 1, directory 2, and step by step, and which will be this of I. I can put it under the for loop so it can be more clear, maybe. And then we will need to read the directory. So this will be the complicated part. First, I will start by making an struct, which will be structure to represent a single file or dir entry. Name, modification, like seconds and nanoseconds. I make so many typos, I hope you can follow it and like don't get confused by them. So again, type def struct struct s file info, which will have the char name. It will have the maximum path name, which is in limits header, and include limits.h. See that? No? Come on. Yes, it is there. Just it takes a second to load. It happens sometimes. I will have long second, because when we say when we give option T, we need to check for the second, which will be st m time dot tv second, and then we will have another long for nsec, which will be the same as st time tv nanosecond, and we will have a bool to check if it is a directory, and this will be our file info struct. Okay, so I made the type. It should be like this. No worries. Okay, so now I have my struct to present my file info, and I will have a second struct for a container for an array of file info t plus a count. So again, type def struct as file list, which we will store the infos as a list. So file info t files, which will have the maximum number of files, and int count. So file list t. What's the problem? Type def struct, and now we need a maximum. So I will define maximum files as 2000. You can change it as you need. I think 2000 is a long number. And there you can, let's say, adjustable. You can change as many as you need, but 2000 is quite a number for me. And yes, now we have a file info struct to get the name, the time, and check if it's a dir. And then we have an array to keep the info and number of the elements in our list. So going back to the main function, and I will basically have like a list of files, file list, which will be read directory, which will have directories, and options dot show all. And now we need a read directory function. I will declare it on my header, which will be to say, it will return a file list t. We will it directories. Did I make a mistake? I hope not. Const. It will get the name of the pet, as you can see here. We gave it a pet, which is directories, and we are giving a boolean number, which is show hidden. And copy this before my main. Okay, now we have our with directories. No, actually, I made another typo, which is with directory. Let's also put it here. Okay. It will with the directory, and what this function will do, just like we did in the other ones, I will make a quick explanation what it does. Open pet as directory, read each entry. We will use readdir. If show hidden is false, we will skip the one start with dot. As you can see here, if I say ls, we have normal files. If I say ls all, it also shows dot and double dots. So if it's show hidden is false, we will not show them. We will skip the one start with dot. We will use lstat to get the stmimtv sec and nanosecond. Just copy this to get sec and nsec, and we will check is there, which is a boolean. We have it in the struct, and then we will return file list t of all the entries found. Okay, so we can start writing the function. We have our file list t f list, and as a default flist dot count equals 0, and when we are done with everything, we will return this flist, and let's start by checking if our pet is a directory or not. I will say opendir, and we will get the pet, and if it is not a directory, it means we can open the directory. We will say printf my ls cannot access access, let's say %s, new line, I will give it what's in the path. So first we check if we can access the directory or not, and then we will have a struct the end, which will be empty. Do I have the header for it? I guess it's okay. Yeah, we have it here. We used it before, yes. And then we will check while that entry is readdir, which is the dir not equals null. So we are checking if we can read the directory, like while we can read the directory. In that case, we will check show hidden, or skip the ones start with dot. So I will say if not show hidden, and so show hidden boolean is 2, and entry dname of 0 equals dot. We will continue. We are checking if show hidden is false and not false is 1, yes. If we don't want to see the show hidden and enter name's first character starts with dot, we will just continue. We will skip that one. And if it is something that we need to print, we will build full path for lstat, which I will say full path, which will have path maximum. I don't remember what was it. Okay, so it's like quite a path, and we will use sn printf function, which will write into the full path that %s, %s, which is the meaning. First I will give it the path, and then I will give the name of that. So for example, if I copy the path for my ls, it will be my workspace. In quote spaces it will be the path and a slash between them, and the name of my file that I will access by lstat. And we have another struct. It is lstat st, just like we did in the other one, lstat, and in this lstat we will give it the full path, and it will check for the structs, and if it is 0, the header for lstat? I think this is. So where's the mistake? Nope. Let's check lstat. Let me see. System stat.h. I think I have this header. Yes, I do. So open. Can I see it? I give it the full path. So this is not in the file value. I will check what's the problem and be back with you in a moment. Turns out I made a simple typo. Now I fixed it. There was a problem with the P. So now we have try full path. It is getting the full path. You're checking path and name of the entry and the path. And we are using lstat to check the full path and stat st, and then we can start fill the file info t, which we have file info t. I will call it info. We will use str copy, and we will copy the info name and the dname. We will copy the entire dname into info name, and we will give it path max -1. So. And when we are done with that, we will say info.name and path max -1 is equals to null termination. Always null termination. Always remember to put a null termination, because this is very long, 4,000. And yeah, we don't want too many data. We always have to have null termination and things. So then we have info second, which will be stat of stm time, and it will be tv sec. Is that correct? Why? And time. stm. No, it's empty. Do I remember incorrectly? This one is that. So info secret is st dot. At the way of the dot stm time. Okay, turns out I forgot. What was that? So let's go back to start. What we need is, I can just check. Where's the stat here? Yes, mtim. We have stmtim. stmtim dot. I'm confused why we don't see it. It's here. Do I have a missing header, maybe? Let's check for the headers. It's in the stats, I guess. Huh. I will find the problem and be back. So after a quick problem finding, to be honest, I didn't understand the problem because in the Linux manual page, I can see that it has smtime, but it doesn't like to work here, and I can even see in the header. But I think it's okay because we can use mtime for this one. And time and second, because time is the time of last modification, and time millisecond is nanoseconds of last modification. I guess this should give the same value as we are looking for, so let's hope it works. Also, I am not sure, but I will put long just in case, because in the header we declared these as long numbers, so just to be sure and not to face with problems in the future, I will also give them long, even though it's long. And we will check if s is there, and we will check st mod and say info dot is there equals to, so we are checking if it is a directory. If so, we are saying it is a directory, else it is not. Info dot is there equals false, and we will add it to flist, list of files that we are using. So if flist dot count is less than maximum files, which just checking, flist dot files and files dot count. Wait, there's a what files? File list dot count is the info, and flist dot count, we are implementing the count of the file list. So basically we are getting the file info, we are saving the time, hopefully, and the name into our info, and also we are getting the if it is like to or not, and we are adding to our file list, and else we will say we exceed maximum number of files, I don't think so, but yeah, it's better to be safe because we are dealing with C. It likes faults. Too many files in the directory, and then we will give it the maximum. Maximum that some entries. What we give is we give it the path, and then we give it the maximum files. So basically it's saying in the path there's so many files, and this is the maximum of files. It is a good practice. I don't think we will even go to that line, but you never know. And we are done with the directory, so I will say close there. The directories used. Yeah. You should never forget to close the directory after you use it. Same with malloc. After if you use malloc, don't forget to free it. And yes, we can step back to our main. So we have a file lists that is the we are using the directories. We can test it. So I made a test function which is void print file list debug. Which will have the constant file list t, the pointer array. I will say printf, new line. It will say it will be a debug, so I want to debugging read directory output. I want to make sure that we get the documents correctly because this is the important part. So printf total files that is %d new one, new line, f list of count, and we will have a for loop int I equals 0, I is less than f list count, I plus plus, and we will print f. First we will print the name, print the number, %d, name will be string, and then we will print second, which will be a long number, so long integer, and second will be same long integer ld, and we will check if it is there, which will be a boolean. So I can have like %t or %s. I will have %s, so it will say true or false. So first will be the I, second will be the f list of the files of I, dot name, we will have this a couple of times. So I think I can just name second and directory. So we have name second and second and is the, and this is our printf statement. Also we will say is there, I will use the lambda function. Yes, if it's yes, it will print yes, or no. And okay, this is my printf statement, and after that I will have another just a line to complete everything. So now I have my file list. Let's print file list debug, and I will give it address of the file list. Let's say make unused variable total. Where is it? We will use it at some point, but for now just $133. ST. Has no number in it as time. I think it has, but sure. STM time. Yes, I want to access the time of last modification of the file data. But there's STM time and second. So time, this should work. It doesn't. I will find the problem and be back with you. Alright, so after a debug session, I noticed some mistakes I made earlier, so we will fix them. First of all, one of my problems, I am reading the directory, but I am getting a struct copy. Instead of that, I will use a pointer to my directory, which will mean that I will just start here, same in my header. So we will return pointer to the file list. And we are using file list, but let's use a pointer because I don't want to face any more segmentation faults. So I will say size of file list t. We are mallocing our f list, and then the malloc, we should check if it's existing. If it's not existing, we will say printf malloc failed, and we will return. You can just exit 1, which means we will exit by error, and instead of dot, now we have a pointer, so we will use an arrow. Okay, I think this should fix some of the problems we were facing. And let's see what else I need to change. So when we are adding our flist, also yes, I want to fix this part. So here, stmt.tv second. Don't even need the longs because these are already long, as you can see in the documentation in the header file. But I will take care of it. Time dot tv and sec for nanoseconds. This is tv second, and getting. So in the lstat, we are checking if the path is existing. File t info. We are copying the name, and we are terminating by null. We are getting the info second, info nanosecond. We will get info that is there, which will be s is there. We will give it st.st mod. So I don't need this one, I guess. And instead of dots, we will use arrows. Flist count is less than maximum files. Flist files, file list count, file list arrow count plus plus. As we have a problem, and I don't know why it shows like this, but I think it should work when we compile. And we need to put the star here. Let's see, make, we have problems. Let's see what are the problems. We can start with this one. I think this. And so in 251, we can just remove the address because it's already a pointer. Again, okay, it's working. My ls. Okay, so now my ls is accessing my current directory, which is lstat. I can see my files. Also, for debugging, we can see the second, nanosecond, and details. So I don't know why there's an error in the VS Code, but it works fine. I would say our read directory is a success. To continue, I will just comment our debug out. We don't need it at the moment. Then now we can start by sort by time and or name. If we have in the options store time, in that case we will need to sort our files by time. I will use qsort function. Qsort has base, member, size, and comparison. So first of all, I will give it flist our files. It will check our files. It will check the count, number of files we need to compare. We will give it size of the file info t, and we will give them compare time. And if we are wondering what will compare time is, we will make another function before the debug. I will say check compare times later for qsort to sort by modification time in a descending order, and if times are equal, we will fall back to alphabetical order, and it will be an integer function compare time, which will have the constant void a and b, which will mean we will basically compare a and b, const file info t star fa, file a equals constant file info t pointer a. We are just giving a type, and same with this one. T star file b is constant file info t pointer b. We will compare by second. If fa second not equals to fb second, we will return which one is larger. So we will check fa second larger than fb second. If that's the case, -1 or 1. Another possibility, if the seconds are the same, we will compare n seconds. Same with the other one, we will return fa and second larger than the and second. If that's the case, we will return -1 or 1, and in if the time is same, then alphabetically. I don't think it will happen, but you never know. So I'll just think compare. We will compare the names in that case. So compare time checks for the seconds. If they're the same, checks for the nanoseconds. If they are still the same, checks for the alphabetical order, which should be a simple function in the idea. Good. We can also declare it in the header file. Paste. In the compare time, gets pointer A and B. Nice. And if that's not the case, I mean, if it's not supposed to be sorted by time, we will sort them. Same again, flist, files, file list, size of file info t. And in that case, we will have another function called compare alphabetical. Alphabetical. I think this is the correct way to type, I hope. And after compare time, I will have in compare alphabetical, which will same again. We will have void pointer A, void pointer B, and just like we did in the operative for qsort to sort by name. In this case, it will be lexically. I think it's, and it will return less than 0 if A is less than B, larger than 0 if A is than B, and 0 if equal. Okay, so same again, we will have constant file info t, file A equals info t, pointer A, and same with the other one. File B is B, and we will return str compare name file name. Basically, we will compare and the str compare, and same as str compare, we will return less than 0 or larger than 0 or equal depending on the lexicographical order of the names. I hate trying to pronunciate these names. And okay, these were our queue sorts, and then we have another print the results. This is like almost the last step, I guess. We will have a function called print file list. We also had a similar one, print file list debugger. It will be flist. Okay, it's weird. I don't have the function yet, so it's normal. And let's get the function. And it will be simple. For my debugger, it will be void in file list. It will get the constant file list t pointer file list. Function definition. Print each file or their name in flist on a line. So it will be almost same as our debugger, but debugger has so many info that we don't need to see in the ls. So I will just say for int I equals 0, I is less than file list found stick, and I plus plus, and we will print the names in a new line, which will be flist files I dot name. And this is basically all we needed to do in our ls function. And of course, after printing results, I will say, I will check if we have directories. The count -1, and we will have a printf new line. If we have directories, we want to give it a space before printing. And let's find where was my. I don't need this. This is for debug purpose. Do I have another? Total. Okay, I think this is all. Make 231. We don't use the total. It happens. I will just say void total. Make my ls, and we have our list of directories. Let's compare with the real ls. Make file part1, part2, my ls, my c, my h, my printf, all looks fine. If I want to my ls, let's see what's inside the part 1. It says make file and lsc, lsh. If I want to try the same with ls part 1, it also has the ls-1 part 1. It looks the same as my output, so congratulations, we have a successful ls implementation. I hope it was not too complicated. And thank you for watching. I will post the code in my GitHub as part 2. I will do some cleaning, but this was basically all. We had some structs for options, file info, file list. We had helper functions. Let's give them all in the list. So we have parse options, gather paths, git directory, compare time, ping time alphabetically, printing file list, and we are debugging file list. And it's still working. Yes. So yeah, everything seems to work. Thank you for watching and see you on the next video.